Hello friends, welcome to Susan and John MathTube. Today we are going to learn about applications of rank. In the previous videos, we learned two different methods to find the rank of a matrix. The first one is called normal form or canonical form, and the second one was called echelon form. In normal form, we used both row operations and column operations while evaluating the rank. But in echelon form, we used only row operations to find the rank. And today we are going to solve a system of linear equations using rank. Now look at this. There are two words, one in yellow and one in green. The one in yellow says a system of equation. So that clearly tells us there will be more than one equation. And we are interested in a simultaneous solution. That means the solution which will balance more than one equation at a time. And the second word, linear equation. Since the word linear equation is given, clearly the variables or the unknowns, for example, ax plus by plus cz, etc., all the unknowns will be of degree 1. It will never be of degree 2 or 3 or any other values, but only of degree 1. Okay, now I will strongly recommend that you watch the first video. In the first video, we talk about the system of linear equations. At that point, you may not have understood the importance of linear equations, but if you watch that video, you will get a clear idea of the geometry of linear equations. Anyway, we will discuss that part in brief now. So, just imagine we have two linear equations. For example, 2x plus 4y is equal to 7 and x plus y is equal to 2. From that first video, I will repeat, if you have not watched that video, pause the video right now and watch the first video in which we discuss the geometry of system of equations. So look at this, we have two linear equations. And in your high school geometry, you have learned that when you have two linear equations, you end up with two lines geometrically. The lines might intersect at one point, or the two lines may be parallel, or the two lines may be coincident. So depending on the three different positions, we may get unique solution or no solution or infinite number of solution. Similarly, if you have three equations and three unknowns, for example, x plus y plus z equal to 1, 2x minus y plus z equal to 5, and maybe x minus y plus 2z equal to 3, you will end up with three different planes. And there will be 7 or 8 different positions, and depending on the position, we will get three possible answers, that is unique solution and maybe infinite number of solutions, and the last option, no solution. Now remember, even if you have more than three variables, we will not be able to plot the graph, or we will not be able to visualize the situation graphically because we don't know about the fourth dimension and the fifth dimension. But still, the same thing happens. We may get unique solution or infinite solution or no solution. Now look at this. If you get unique solution or infinite solution, you are able to solve, you are able to find a value which will balance all the equations simultaneously. And that situation is called consistent. We say the equations are consistent. Now, if you are not able to solve, then There will be no simultaneous solution for the equation. And we say the equations are inconsistent. Once more I'll tell you. Let's say we have a system of linear equations. And there are three possibilities. You may be able to solve and you might get unique solution. You may be able to solve and you might get infinite number of solutions. And the third possibility, you may not be able to solve. That means no solution. So if you get infinite solution or infinite solution, that means you're able to solve. And that is called a consistent system of equation. If you are not able to solve, then the system will be called inconsistent. Okay, now the next thing we are going to discuss is how to use matrices in solving equation. Because I started this video by claiming we'll be applying the concept of rank to solve a system of equation. For that, I'll take a small example. Let's look at the situation. 2x plus y is equal to 7 and x plus y is equal to 1. So I have two linear equations in two unknowns x and y. Now look at this. I'm going to take the matrix, or it's called the coefficient matrix 2, 1, 1, 1. So I just collected all the coefficients. So 2, 1, 1, 1. Now what I do is I'll collect all the unknowns inside the matrix capital X. So the unknowns are x and y. Now the last thing to do, I'm going to collect the constants on the right side, that is 7 and 1. Now look at this. Suppose I write ax is equal to b. Look at this. I'm going to write ax equal to b. So let's try multiplying a and x. So 2, 1, 1, 1 and then xy is equal to 7, 1. I'm sure you have learned about matrix multiplication. So without any trouble, you'll be able to multiply these. So when you multiply, you get 2x plus y is equal to 7 because of equality of matrices. And the second row, x plus y is equal to 1. So look at this. Our system of linear equations can be written in the form ax is equal to b. I'll repeat once more. We started with a system of linear equations. The same thing can be converted into matrix format using the equation ax is equal to b, where a stands for the coefficient matrix and x stands for the column matrix which contains all the required unknowns. And of course, b will be the column matrix which contains the constant terms, which in the standard format will belong to the right hand side. Now I'll explain the method. So look at this. Given any system of linear equation, you have to put it in the form ax is equal to b. So once more I'll repeat. A stands for the coefficient matrix and x the column matrix which contains all the unknowns, and b of course the column matrix which contains all the constants. And the method is, first you form something called the augmented matrix. So you join A and B together and form something called augmented matrix. And the second thing to do is to find the rank of C. So you're going to find rank of C using echelon form. Now look at this. You have solved equations in your younger classes. And when you solve equations, you know that you never use column operations. You always multiply the first equation by 2 and subtract. You multiply the second equation by 3, add them, etc., etc. You never use column operations. So remember, find the rank of C but use echelon form. Now C consists of A and B. So if you hide the last column, then you'll be able to find rank of A. And I'd write one more thing, the number of unknowns. Now by comparing these three quantities, we'll be able to conclude whether our system is consistent or inconsistent. And if it is consistent, we'll be able to conclude whether it has unique solution or infinite number of solution. So you can write down the conditions. Now look at this. If rank of C is equal to rank of A is equal to the number of unknowns, then we get unique solution. At the same time, if rank of C is equal to rank of A, but this quantity is less than the number of unknowns, then we get infinite number of solutions. And the third condition, if rank of C is not equal to rank of A, then we have inconsistent system. That means no solution. So I want you to note this point. Now let's work out one problem and understand the concept clearly. So write the first question, test for consistency. So what do you mean by the word consistency? You're going to check whether you'll be able to solve the system of equation or not. By the way, remember, if you're able to solve the system, you still have two possibilities. You may get infinite number of answers, or you may get one and only one answer. Okay, so please write the question, test for consistency and solve. Okay, and we have the system x plus y plus z is equal to 6, x plus 2y plus 3z is equal to 10, and the third equation, x plus 2y plus 4z equal to 1. Okay, now look at this. You're given a system of equations in how many unknowns? Yeah, you're right. 3 unknowns, x, y and z. So, we are given 3 equations in 3 unknowns, and the question is test for consistency. And if it is consistent, we have to solve them. Okay. Given any problem in which we are asked to test the consistency, the first thing to do is you have to write capital A. Capital A stands for the coefficient matrix. So the coefficients of the first row are 1, 1, 1. And for the second row, it's like 1, 2 and 3. And for the last row, 1, 2 and 4. Now capital X. What was capital X? Yeah, the column matrix. The column matrix which contains all the unknowns. So how many unknowns are here? 3. And what are the unknowns? X, Y and Z. And finally, capital B, that is the right side, and that will be 6, 10 and 1. Okay. Now we know that capital AX is equal to B is the matrix equivalent of this system. So remember, the matrix equivalent of this system is AX is equal to B. Now let's start with the method. The first thing to do is you have to form the augmented matrix. So you can write the augmented matrix is given by AB. That is, we augment A and B. That means we write A and B together. And we get a pretty big matrix. And that will be 1, 1, 1. And the second row 1, 2, 3. and the last row 1, 2, 4. Now let's augment it with B. Let's combine B, and that gives me 6, 10, 1. So I hope you understood how to augment the two matrices A and B. So look at this. We have A, we have B, and this is the combined version. Now what did I tell you? What's the second thing to do? We have to find the rank of C. Automatically, by hiding the last column, we will be able to find the rank of A. And always remember, we are allowed to use echelon form, not normal form, only echelon form. And in echelon form, we are not allowed to use column operations. And that's quite sensible. When we solve equations, we never subtract or add or do anything in column manner. We do all these operations row wise. Okay, let's start. Let's find the rank. So I'm going to put my equivalent symbol, and I hope you remember the rule. The first element should be made 1. It's of course 1. Now you're supposed to make all the elements beneath this to zeros. So I'm going to write the first operation. R2 changes to R2 minus R1, and R3 changes to R3 minus R1. So we get 1, 1, 1, and then our 6. Now look at this. The second row is going to change, and the third row is also going to change. So 1 minus 1, 0, and then 2 minus 1, then we get 2 and 4. And the last row 0, 1, 3, and minus 5. Now we go for the next operation. So look at this. We have 1 and all the elements beneath 1 are equal to 0. Now let's move diagonally, or let's go to the second row and find the first non-zero element. We have to make that element 1. Voila, it's already 1. So the next thing to do is we have to make the element just beneath this 1 into 0. So I'll write the operation. R3 changes to, because my target element is in the third row, R3 minus R2. So 1, 1, 1, and then 6, 0, 1, 2, and then 4, and then our operation. So it will be like 0, 0, 1, and minus 9. Okay, now look at this. We already reached echelon form. If you want to confirm, it's very easy. The first element is 1. All the elements beneath 1 is equal to 0. The first non-zero element in the second row is 1, and all the elements beneath that 1 is equal to 0. The first non-zero element in the third row is 1, and there is no more elements beneath that 1. That means we have reached the echelon form. Now look at this. In echelon form, the rank is given by number of non-zero rows. I hope you still remember that part. So let's count. The first row is non-zero, the second row is non-zero, the third row is non-zero. So what do you mean by a zero row? Zero row means all the elements in the row should be equal to 0. So what do you mean by non-zero row? If at least one element in a row is non-zero, then that row will be called a non-zero row. So how many non-zero rows are there? Okay, 3. Now I told you earlier, once you find the rank of C, you will be able to find the rank of A very, very easily. All you have to do is, you have to forget about the last column. So for the time being, let's ignore this. For the time being, let's ignore this and let's focus on this part. Okay, now tell me how many non-zero rows are here. It's the same. So rank of A, do you still remember? We found C by augmenting A and B together. And we did only row operations. So that means this part, the bigger circle, is going to give us the rank of A, which is equal to number of non-zero rows, that is equal to 3. And now the last thing, how many unknowns are there? In the beginning itself I told you the unknowns are X, Y and Z. We have the condition rank of A is equal to rank of C is equal to number of unknowns, and this is the condition for unique solution. So look at this. Our conclusion is we will be able to solve our system. That means our system is consistent. And second thing, our system has one and only one set of solution. Because rank of A equal to rank of C, we can claim that our equation is consistent. And since that is equal to the number of unknowns, we are able to claim that our solution will be unique. That is, we will get one and only one set of solution. So what we do is we take this last matrix. I will copy that last matrix for you. The last matrix is 1, 1, 1, and then we have a 6, then 0, 1, 2, and then we have 4, 0, 0, 1, and then we have a 9. Now look at this. You have to learn to read the equations from here. This is A and this is B, and I told you the matrix equivalent is AX is equal to B. So you can easily read the equations from this matrix. X plus Y plus Z is equal to 6. The second equation is Y plus 2Z equal to 4. And the third equation is Z is equal to minus 9. So that's it. The value of Z equal to minus 9. And then I'll write the next equation. Y plus 2Z equal to 4. But I already know the value of Z. So Y minus 18 is equal to 4. So Y is equal to 22. Now I'll read the first equation. X plus Y plus Z is equal to 6. That is X plus 22 minus 9 is equal to 6. And that gives me X is equal to minus 7. So I'll write the conclusion once more. Since rank of A equal to rank of C, the system is consistent. But I told you earlier, a system is consistent implies two things. Maybe the system will have infinite solution, or maybe the system will have unique solution. Now take a look at this. Rank of A equal to rank of C, and that is equal to the number of unknowns. So that gives me a very clear idea. It is consistent and we have unique solution. And then what I did is I took the last step. I took the matrix after reducing to echelon form. And with the help of this matrix, I am writing the equations one by one. So the first equation is X plus Y plus Z is equal to 6. The second equation is 0x, so I just ignored it. Y plus 2Z equal to 4. And the last equation gives me the value of Z, and which is equal to minus 9. I just plugged in this value in the second equation. I found the value of Y. And finally, I found the value of X using the first equation. So our solution is minus 7, 22, minus 9. So let's move ahead. I hope you're ready for the next question. So please note the question. Test for consistency and solve if possible. I'll repeat. Test for consistency and solve if possible the system of equations x plus y plus z equal to 4 and then x plus y plus 2z is equal to 2 and the last one 2x plus 2y plus z is equal to 5. So look at this. You're given a system of linear equations. To be exact, we have 3 equations in 3 unknowns x, y, z. So tell me, what is the first thing to do? You collect the coefficient matrix inside A and then the matrix which contains all the unknowns as a column matrix, and finally B is equal to the right side, the constants 4, 2 and 5. Okay. And once you do this, you'll be able to augment the matrix A and B. So first you collect all the coefficients, then the unknowns, and then B, and finally augment the matrix. So shall we start? So the coefficients will be 1, 1, 1, 1, 1, 2, 2, 2, 1, and the right side is 4, 2 and 5. So look at this. C is equal to, I'm going to augment A and B. So 1, 1, 1, 1, 1, 2, and finally 2, 2, 1. And let's join 4, 2 and 5. Okay, now what's the second thing to do? You have to reduce the matrix C into echelon form. And when you use echelon form, don't forget you are allowed to use only row operations, no column operations at all. So I'm going to write R2 changes to R2 minus R1 and R3 changes to R3 minus 2R1. And as usual, there is no change in the first row. So we are going to get 0, 0, 2 minus 1 is 1, and then minus 2, 0, 0, minus 1, and 5 minus 8, that will be minus 3. So look at this. The first element is 1. All the elements beneath that 1 are zeros. Now I will find the first non-zero element in the second row. So now my job is, it's already 1. So I have only one thing left to do, that is to convert the element just beneath this into 0. So I'm going to write the operation now. So I will write R3 changes to, so this is my target. So R3 plus R2, because I am supposed to make this element 0 using this 1. So only the third row will change. 1, 1, 1, 4, 0, 0, 1, and then minus 2, and then 0, 0, minus 1 plus 1, minus 3, that will be minus 5. Now look at this. We are already at the end. We have the echelon form. So the first element is 1 and all the numbers beneath this are zeros. The first non-zero element in the second row is 1 and all the elements beneath that 1 are zeros. And the first non-zero element in the third row is minus 5, and I can make that one very easily by multiplying throughout by 1 by 5. Okay, anyway, I'm not going to waste my time doing that. If you want, you can make it 1. Okay, so I'll write rank of C. So how many non-zero rows? Okay, first row is non-zero, the second row is non-zero, the third row is also non-zero. And now I'll write rank of A. It's very easy. You hide or you forget about the last column and focus on the rest. Okay, first row is non-zero, the second row is non-zero, the third row is a zero row. That means the rank is equal to number of non-zero rows, that is equal to 2. Okay, so look at this. Rank of C is not equal to rank of A. Earlier I told you, if rank of C and rank of A are not equal, then the system will be inconsistent. That means you will not be able to find a unique solution or infinite solution. That means you will not be able to find a simultaneous solution, or you will not be able to find a solution which will satisfy all the equations together. I'll repeat what I told you long back when I started the video. If you want to understand the geometrical meaning, then make sure you watch the first video in which we discuss about the geometry of linear equations. Anyway, I'm going to end this video right now over here. But I'll be back with more problems in system of linear equations, because we have to learn how to find or how to solve equations when we get infinite solution. So I'll be back soon with the next video, and if you like the video or if you find the video useful, please like, share and subscribe. So till then, bye.